Alright guys, welcome to today's class. In today's class we shall be talking about asymptote of a function. In our previous class we have defined the concept asymptotes and we have talked about how to find the vertical asymptotes. And I want to do a recap. We say that we have three types of asymptotes. We have the vertical asymptotes, we have the horizontal asymptotes, then we have the slant or the oblique asymptotes. And we define the concept asymptote as a straight line that a curve approaches closely as independent or dependent variable tends to infinity, or in a general sense that an asymptote is defined as a straight line that is either parallel to the horizontal axis or parallel to the vertical axis, or a straight line that forms an angle less than 90 degrees along the x-axis in the Cartesian plane. All right, we shall be talking about horizontal asymptotes. Okay, horizontal and slant at the same time. Slant asymptotes. We'll talk about the horizontal and slant asymptotes. Now, don't forget that the general form of all rational function is given as f of x equals to nx divided by dx, right? Where ns can be represented as anx to the power of n plus a2 x to the power of 2 plus a1 x to the power of 1 plus a0, right? X to the power of 0, then x to the power of 0 is 1, then divided by, let's use b to represent this, b m x to the power of m plus dot 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 b2 x to the power of what? Of 2 plus b1 x to the power of 1 plus b0, where n represents the degree of the numerator, where n represents degree of the numerator, m represents the degree of the denominator. The word degree simply means highest power, right? Don't forget the highest power. The word degree, when you hear the word degree of the numerator, it means the highest power. Since the power is decreasing, so that means the highest power is n. Since the power is decreasing from 2 to 0, the highest power here is what is m. All right. Now we have three conditions for a rational function to be horizontal, to have an horizontal asymptote. Don't forget that horizontal asymptote occur at y equals to a given value. It can either be y equals to 0 or y equals a given number, right? Or we can also not have an asymptote, sorry, horizontal what? Asymptote. Are you there? Now let's look at the three conditions. The three conditions as regard horizontal asymptote. The three conditions as regard horizontal asymptotes. The first condition is, number one, when the degree of the numerator is equal to the degree of the denominator. When the degree of the numerator equal to the degree of the denominator, how do we find the horizontal asymptote? If the degree of the numerator is equal to what? The degree of what? Denominator. The horizontal asymptotes occur at y equals an over bm, where an represents where an and bm represent the coefficient of the leading variable, the coefficient of the leading variable. Okay, this is the first condition as regards to horizontal what asymptote, or the first steps you have to take note of is that if n equals to m, n represents what? The degree of the numerator, m represents the degree of what? Denominator. Degree means the highest power. So for this polynomial here in the numerator, the highest power is n. Are you there? So coefficient of the highest power here is what? Is an. While that of the denominator, the coefficient of the highest power here is what? Is bm. So m represents degree of what? Denominator. N represents degree of what? Numerator. Now the first condition is that when m equals to m, meaning when the degree of the numerator and that of the denominator, they are the same, it means that horizontal asymptote occur as y equals to an divided by what? Bm, where we say that an and bm represent the coefficient of the leading variable. I've already shown us what an represents here. Coefficient of the leading variable is this, right? This is the leading variable. What is the leading variable? It means the variable with the highest power that has the highest degree. Exactly. So obviously, since the power is decreasing, this becomes the leading variable. So the coefficient here is an. What about this? Bm. So when we divide this by this, that will give us the value of our asymptotes, our horizontal what? Asymptotes. So our HA occur as y equals to an divided by bm. Let's see condition 2. Condition 2. We have seen condition 1. Condition 2. If n is less than m, if n is less than m, look at this. This is saying that if the degree of the numerator, right, is less than the degree of what? Denominator, meaning that if the rational function is bottom AV, bottom AV, bottom AV simply means that the degree of what? The denominator is higher than that of what? The numerator. For example, if I have 2x over 2x cubed plus 4x plus 6, the degree of the denominator is 3, while that of the numerator is 1. So this is bottom AV. Are you there? Now, what we are saying here is that if the degree of the numerator is less than what? That of what? Denominator. Therefore, horizontal asymptotes occur at y equals to 0. Please take note. It will occur at y equals to 0. HA will occur at y equals to 0. Whenever n is less than m, n represents degree of the numerator, m represents degree of what? Denominator. Degree means the highest power. So we are saying that if the highest power in the denominator is less than that of what? Is more than that of what? Sorry, numerator. Meaning if n is less than m, the degree of the numerator is less than the degree of what? Denominator, meaning bottom AV. HA occur at y equals to 0. Let's see, number 3. If n is greater than m, this is simply top AV, right? Top AV. In this case here, if the degree of the numerator is greater than that of the denominator, it simply means there is no horizontal asymptote. There is no horizontal what? Asymptote. All right? There is no horizontal asymptote. If the degree of the numerator exceed that of the what? Denominator, meaning the rational function is top AV. Top AV means that the power here is greater than the power here. So it means there is no horizontal asymptote. Now, the last condition that will lead us into slant is that if n, the fourth condition, if n is greater than m, we have seen that there is no horizontal asymptote. But if n exceed m by 1, there is a slant asymptote. There's a slant asymptote. I will explain. What I mean by that is that if n is equals to n plus 1, we have what we call slant what? Asymptotes. If n is equals to n plus 1, we have what we call slant asymptotes. Now, let me give an illustration. If I have this, look at this. If I have a function here, f of x is equals to s squared plus 2s plus 4 divided by, let's say, s plus 3. What you notice here is that the degree of the numerator is greater than the degree, n is greater than what? Than m. Already we have said that whenever the degree of the numerator, the degree means the highest power. The highest power here is 2, the highest power is 1. So that means my n is greater than m. So it simply means there is no horizontal what? Asymptotes. But if you look at this now, n is greater than m by 1. N exceed m by 1. The difference between this power and this power is what? Is 1. So since the degree of the numerator is greater than what? That of our denominator by 1, that means that we have a slant asymptote. It means there is slant asymptote. Okay, what if I have something of this nature? I have s cubed here. I have 2s squared plus 4s plus 6. Then let's say I have a function like s squared plus 3s plus 5. What do we notice here again? The degree of the numerator, which is 3, right, exceed that of what? Denominator by 1. It simply means we have a slant of asymptotes, but there is no horizontal asymptotes. The only condition for us to have horizontal asymptotes is, number 1, if n is equals to what? M, right? Number 2 is that if n is less than what? M. But whenever n is greater than m by 1, or by 2, or by 3, there is no horizontal asymptotes. But if n exceed m by 1, it means there is a slant what? Asymptote. Okay. In general, we say we have 3, right? 4 conditions, or 3 rather. The first is when n equals to what? M. It simply means our horizontal asymptotes occur, right? Occur at y equals to an over bn, right? Okay. Number 2 is that when n is less than m, it means horizontal asymptotes occur at y equals to 0. Number 3, when n is greater than m, it means no horizontal what? Asymptotes, right? No horizontal asymptotes. Number 4, when n exceed m by 1, meaning n equals to m plus 1, it means there is a slant, right? There is a slant asymptote. A slant asymptote. Okay, this is just how to differentiate between horizontal and what? And slant asymptote. But don't forget that, note that slant asymptote, slant or oblique, have a general form. The general form is y equals to mx plus c. Y equals to mx plus c. That is the general form of an oblique asymptote, or a slant what? Asymptote. Take note of this, horizontal and slant. Take note. Let's proceed. All right, we have a question here. We are given a question to solve. We have 4 questions, and we have to find the horizontal asymptote of the following. The first one is f of x equals to 3x minus 4 divided by 2x plus 6. Okay, and the second is this, third, and the rest. So let's look at the first one we have here. F of x equals to 3x minus 4 divided by 2x plus 6. If you look at this question closely, you'll find out that the degree of both the numerator and denominator, they are the same. The degree here is 1. The degree here is what? 1. So this falls in the first condition that says when n equals to what? M. To find the horizontal asymptote, we have to divide the coefficient of the leading variable, right? The leading variable here is x. Here is what? Is also x, right? Coefficient of x here is 3. That of x here is 2. So that means our horizontal asymptote occur at y equals to 3 divided by 2. This is just it. Or HA occur here. Now let's look at this also. The coefficient of the leading variable in my denominator is 5. Y here is what? Is -2, right? Okay. The degree here is 1, degree here is 1. So this also falls in the condition that says n equals to what? M, right? So that means I will divide -2 by 5. It means that our HA occur at the point -2 divided by what? 5. -2 divided by 5. Just divide the coefficient of the leading variable, which is -2 and 5. Divide the coefficient. That will give us the point at which HA occur. So HA occur at y equals to -2/5. Look at this here. What do you notice here? The degree of the numerator is less than that of what? Denominator. 1/x can also be expressed as 1x to the power of 0 divided by x, right? The degree here is 0, the degree here is 1. So that means our n is less than what? M. Okay, so and we say that whenever n is less than m, it simply means that HA, right, will occur at y equals to 0. Whenever the degree of the numerator is less than that of what? Denominator, meaning the function, okay, is bottom AV. Bottom AV means that we have more power here than here. The power here is 1, as seen here. The power here is 1, the power here is what? Is 0. So that means our n is less than m. So HA occur at y equals to 0. You can tell me the answer to this. The same thing. Yeah. HA also occur. HA occur at y equals to 0. Because this can be expressed as 7x to the power of 0 over what? X minus 3. So the degree of the numerator here is 0. Here is what? Is 1. So the same thing, n is less than what? N. So our HA also occur at y equals to 0. Let's see another example. Okay, we have a question that said find all the asymptotes of the function. When they say find all the asymptotes, that means find both the horizontal and vertical. Then if there's slant, you can also find the slant asymptotes. So let's look at the horizontal asymptotes. The first one, horizontal asymptotes. Already we have seen that our n is less than m, right? The degree of the numerator is 0. Right, that of the denominator is what? Is 2. So 0 is less than 2. So that means n is less than what? 2. Therefore, our HA occur at y equals to what? 0. That is for this. Number 2, let's look at vertical asymptotes. In my first class, if you have not watched the video, please go and watch the video on vertical asymptotes. On vertical asymptote, we say that we have to set our denominator to be equal to 0. That if we are given a function f of x equals to nx over what? Over dx. I say to find vertical asymptotes, right? We have to set our nx equals to 0 and find what? Sn, right? Also set dx equals to what? 0 and find SD. Then we say that if Sn is equals to SD, we said there is no what? Vertical what? Asymptote. But if Sn is not equals to SD, we said there is a vertical asymptote. Well, let me repeat here again. But if Sn is not equals to what? SD, we say there is a vertical what? Asymptote at SD, sorry, at dx equals to what? 0. I repeat again. If Sn equals to SD, there is no vertical asymptote. But if Sn is not equals to SD, we say there's a vertical asymptote at ds equals to 0. Meaning that when we set our ds equals to 0, any value of s we have is referred to as what? Our vertical what? Asymptote. Now let me give an illustration here. Let me solve with this. What do we notice here? In this function, our numerator is just a single number. So there's no need of setting numerator to be equal to 0. So what do we do? Just to set this equals to 0. Your vertical asymptote always occur at ds equals to what? 0. But if I have a function here, I have to set that function equals to 0. then set this also equals to 0. Then compare the answers. If the value of x here and the value of x here are the same, that's what it is saying. It said there is no vertical asymptote. But if the value of x here and the value of x here are not the same, if both the numerator and denominator does not have the same value of x, it simply means there is a vertical asymptote that occur at ds equals to what? 0. And the value of ds equals to 0 is always sd. All right, now let's go. I will give more example. Just follow up this class. So since we are given that y equals 4 over s squared plus 1, and we also find the vertical asymptotes. For this, we have seen that the numerator is not a function, it's just a constant. So it simply means I will set only my what? My denominator to be equals to 0. So I'll set the x equals to 0. And that will give us what here? S squared minus 1 equals to 0. I can simplify this further using difference of 2 squared. This is same as s squared minus 1 squared equals to what? 0, right? Okay, so if that is the case, that will give us x plus 1, x minus 1 equals to 0. We call it difference of 2 squared. The general form of this is simply a squared minus b squared is a plus b times a minus b. That was what I did here. Minus 1 squared is same as minus 1, right? So let's continue with this. So that means the general form becomes this, right? Now, this simply means x plus 1 equals 0 or x minus 1 equals 0. Therefore, I can say that x is equals to minus 1 or s is equals to what? 1. So that means that our vertical asymptote occur at s equals to minus 1 or s equals to what? To 1. This is the point at which vertical asymptotes occur for this function. But don't forget that there is no horizontal asymptote because n is less than m. Like I said, please go back to the previous video I did on vertical asymptote for clarity. Let's look at this question that said find horizontal asymptote of the following. The first one is y equals 3 divided by s plus 7. The same thing we've been doing so far. The degree of the numerator is less than that of the denominator. So here, our n is less than m. So therefore, that means HA occur at y equals to 0, right? HA occur at y equals to 0. Look at this also. We are giving y equals to 3 over s plus 7 plus 3. The degree here, the whole of this is same as this, and the answer is 0. So that means to find my HA, our HA occur at y equals to, this is 0. Why do we say here is 0? Because the degree here of the numerator is less than that of what? Denominator. So that means 0. Then we have plus 3. So our HA occur at y equals to 3. Don't forget, whenever you have something of this nature, just add up the 3 to whatsoever you have here. All right, okay. So the next one here we have is that we have to find HA. The degree of the numerator is 1, right? Our n is 1, our m is 2. What do we notice here? N is still less than what? N is still less than m. Yeah, n is less than m. So since n is less than m, that means our HA also occur at y equals to what? 0. HA occur at y equals 0. Let's look at this together. Solution to this. If we are giving y equals 8x minus 6 divided by s squared plus 3s, the whole of this here is the same thing as this, right? This and this are the same. So the value we got here is 0. So that means our HA for this question occur at y equals to, what we have here is 0. 0 minus 9. Our HA occur at y equals to minus 9. Please take note of this. Y equals to minus 9. Take note of this. The next question says find HA of the following. Find HA of the following. Okay, the first one we have here say y equals to 12x minus 6 divided by 3s plus 4. Y here represents f of x. Okay, we can either use f of x or we use what? Y, right, to represent f of x. Okay, so look at this now. The degree of the numerator and that of the denominator, they are the same. Yeah, since our n is equals to what? M. What do we say we do? We divide 12 by 3, right? Now, the leading variable here is x. So what do we say we do under this condition? We divide their coefficients. Divide 12 by what? By 3. So that means our HA will occur at y equals to 12 divided by 3 minus 2. Minus 2. Here we have minus 2. So when you divide this by 3, subtract this value from this, bring out the minus 2. And that will give us what here? That will give us y equals to 12 over 3 is 4. 4 minus 2. The answer is 2. So that means our HA occur at y equals to 2. What about this expression? Okay, the degree of the numerator is the same as that of what? Denominator, right? For this question here, we have s squared, we have s squared. So what we do, the same concept, we divide their coefficients. Coefficient of s squared here is minus 8. Since n is equals to what? M, right? The degree of the numerator is same as that of what? Denominator, right? So I will divide. That will give us y. So HA will occur at y equals to, let's go. Here we have minus 8 divided by 2 minus 5. That will give us minus 4 minus 5. Therefore, y equals to minus 9. So HA occur at y equals to minus 9. Minus 8 divided by 2 is minus 4. Then minus 5 again, we have minus 9. Okay, let's look at this question here. Yeah, what you notice here is that n is greater than what? M. The degree of the numerator is 2. That of the denominator was 1. Yeah, our n is 2. M is 1, right? So n is greater than m. So since the degree of the numerator is greater than that of what? Numerator, it simply means there is no horizontal asymptotes. There is no horizontal asymptotes. But we have a slant asymptote because the degree of the numerator is greater than that of the denominator by what? By 1. Meaning n is equals to m plus what? Plus 1. The difference between this and this, the difference is 1. So since the degree of the numerator exceed that of what? The denominator by 1, it means I can find a slant asymptote. But for now, since the question says find HA of the following, okay, I will just stop at this for now. In my next example, I will bring back this to solve for slant asymptotes. Now let's go. For this, the degree here is 1. Degree here is 1. The same case with the first and second example. Here n is equals to m, right? So what do we do to find the horizontal asymptotes? Is by dividing 2 by 1. So we have 2 over 1. The answer here is 2. Final answer. Now let's find this. Let's find the slant asymptotes with this. Since we are saying that our n exceed m by 1. So the degree here is 2. Here is 1. So there's a slant asymptote. How do we find slant asymptotes? Okay, this question says find the slant asymptotes of this function. Find the slant asymptote of this function. Okay, if you look at this very well, the degree of the numerator, the degree here is 2. The value of n is 2. The value of m here is 1, right? Okay, the degree of the numerator exceeds that of what? The denominator. So this simply means that there is no horizontal asymptote. No HA, right? No HA. No HA. Okay. All right, we have seen the condition for HA to occur. Right? HA occur when n equals to m or when n is less than m. But whenever n is greater than m, it means there is no HA. But there's a fourth condition that says when n is greater than m by 1, it simply means there's a slant asymptote, meaning that when n is equals to m plus 1, it means we have a slant asymptote. Look at this function here. N is 2. N means degree of the numerator. M means the degree of the denominator. The degree of the numerator is 2 and is greater than the degree of what? The denominator by 1. Right? Meaning n exceed m by 1. So that means there's a slant asymptote. Now the question is, how do we find a slant asymptote? Well, don't forget that a slant asymptote have a general form of y equals to mx plus what? Plus c. Okay, the general form is this, meaning a straight line graph that meets the x-axis at an angle less than 90 degrees or forming an acute angle, right? Or we can say that a slant asymptote have a slope a slope of tan theta, right? A slope of tan theta. Let me don't go into it because my next class on graphing, I will explain slant asymptotes and horizontal asymptotes and that of vertical asymptotes. But just take note that slant asymptotes forms a general form of ms plus what plus c. All right. Now, how do we find a slant asymptote? Is by dividing the numerator by the what denominator using long division polynomial method. Using long division polynomial, meaning dividing nx by what? By dx. Okay, so let's see what we're going to generate from here. Now let's divide and see. Our nx is s squared plus 5x plus 6, right? Our ds is s plus 3. Okay, so the result of this division is actually the slant asymptotes. And that result is called the quotient, right? Which should be placed somewhere here. Now let's divide and see. So divide s squared by x. When divide s squared by x, the result will be s, right? Divide s squared by x, we have x. After dividing s squared by x, the next is to multiply this x by x and 3. So s times x will give us what? Here we have s squared. The same x times 3 will give us plus 3x. After multiplying, we subtract this and this. So subtract the whole of this with this, right? So s squared minus s squared is 0. Here we are left with 5x. 5x minus 3s will give us what here? 2x. 6 minus 0 or minus nothing will give us plus 6. All right. When you subtract 6 minus and nothing here, okay, the other term here is 0. So 6 minus 0 is 6. Or we can just say bring down the 6. Just bring it down this way. Now, what you notice here is that the degree of this function is the same as the degree of this function. So I can further divide again, meaning I can divide 2s by x. That will give us what here? 2. The same thing we did here, we repeated again. I'll multiply this 2 by x, this 2 by 3. So let's go. So 2 times x will give us 2x. 2 times 3 will give us what? 6. After multiplying, I will still subtract again. So 2x minus 2s is what? 0. 6 minus 6 is what? 0. So what is our quotient here? Our quotient is x plus 2. The slant asymptotes occur at y equals to the quotient, which is y equals to x plus what? 2. X plus 2. Okay, this is the answer here. By the time we compare this with the general form, y equals to ms plus c, it simply means that our slope is 1, right? But our c is equals to 2. The intercept is 2. So that means that a graph of y against x is a straight line graph meeting the y-axis at y equals to what? 2. Okay, let me just show us the graph here so you can understand. A graph of y against x. Okay, let's say we have here as 1, we have here as 2, we have here as 3, we have here as 4, and here as 5. So this graph we move this way. Sorry, this graph we move this way. Okay, we move this way. This is a graph of y equals to s plus 2. Any curve that is being plotted that approaches this line is called a slant asymptotic graph. But in my next class, I'll be talking about how to plot HA graph, VA graph, and SA graph. By HA means horizontal asymptotic graph. VA means vertical asymptotic graph, while SA means slant asymptotic graph. We look at different equations and the nature of their graphs for each of the equation. All right. Okay, that is just all for now. Now let's see another example. We are given y equals 2s cubed plus minus 8x rather plus 6. Then we have here s squared plus 4. And we are asked to find the slant asymptotes. Already there is no horizontal asymptote because it exceeds. So we don't have no HA, but there's a slant. Okay, so how do we find the slant? I want to divide this with this, right? Using long division method. So I will divide. Let's divide and see what will be the result. Here we have here as s squared plus 4. Here we have here as 2s cubed plus 0 s squared minus 8x plus 6. In a polynomial, the power will always decrease from the highest to the lowest. If the power here was 3, the next must be 2. So that means that we have s squared, but the coefficient of s squared is 0. So that 0 times s squared will still be 0. So the whole of this is same as this. All we just did there, we just to add 0s squared to enable us to divide. Without this, I can't be able to divide, all right, properly. Now let's go and see. Let's see. So let's divide 2s cubed by s squared. When you divide 2s cubed by s squared, all right, that will give us 2x. So here we have 2x here. Multiply 2s by s squared, that will give us 2s cubed, right? Multiply 2s by 4, that will give us 8x. Is that clear? So what do we do here? We subtract, right? When we subtract 2s cubed minus 2s cubed, we cancel out. All right? Okay, so let's proceed. Here, we're going to have here as minus 8x minus 8x is minus 16x. All right? So here we have here. Okay, let me reduce this. Let me bring down this. Let's check this out. 0s squared minus nothing is what? Is 0s squared, right? Okay, let's take it this way. Here we have 0s squared. Here we have minus 8x. Minus 8x is minus 16x, right? So what we say we're going to do here, we bring down the 6, right? Or we say 6 minus nothing is same as 6. Okay, so what we notice here is that the degree here is what? Is 2. Here is 2. I can further divide. So divide 0s squared by s squared. That will give us 0. So it means I'm going to have 0 here. Okay, so 0 times s squared will give me 0s squared. 0 times 4 will give me what here? Okay, will give me, okay. So when we further divide, minus this we subtract, abi, we are left with minus 16 minus 0s will give us what here? Minus 16x. Here we have 6 minus nothing will give us what here? Plus what? 6. Are you there? So what you notice here is that the degree of this function is less than that of what? Of this function, right? Meaning the degree here is what? Is 1. Here is what? 2. So I cannot further divide. I will stop here. This becomes my remainder. This is my remainder, right? This is my remainder. I have a remainder here. For the first one, if you notice when we subtract, we have 0, 0. I mean, there's no remainder. But for the, we have a remainder. But that does not affect the value of your slant asymptotes. Any linear function we have as a quotient remains the slant asymptotes. So that means that my slant asymptotes occur at y equals to what? 2x plus 0, which is same as y equals to what? 2x. This is my slant asymptote. Our slant asymptote occur at y equals to what? 2x. Look at this equation here. What do you notice here? In the general form, y equals to ms plus c. When you compare this with this, that means there's no intercept. So this graph will start from the origin. Because there's no intercepts. All right, we start from the origin. Okay, so this is just how to find slant asymptotes. I want to believe that this part is very clear, right? If you have any question regarding this, please let me know in the comment section. Okay, this question says that we should find all the horizontal asymptotes, find HA in all. So look at this here. The degree here is 2, degree here is 2. So since they have the same degree, since n equals to m, so that means our horizontal asymptote occur at y equals to 2 divided by minus 5. or 2 over minus 5, which is same as minus 2 over 5, right? Minus 2 over 5. Just divide this with this. Divide the coefficient. That is all. Now for this, let's verify here. Yeah. N is less than what? Than M. N is less than what? M. Whenever N is less than M, we say that our horizontal asymptote occur at y equals to 0. Okay, for this, the same thing here. Okay, our HA here is 0, right? Sorry, the power of x here is 0. Is that not? Okay, that means here N is also less than what? M. So our horizontal asymptote here is simply y equals to 0 plus 4. The answer here is 4. Let's verify this one here. Okay, the degree of the numerator is 3. This is also 3. So n is equals to m. So what do? We have to divide this 8, right? 8 by 4. That will give us 8 over 4. Then plus this 3 we have here. So our horizontal asymptote occur at y equals to 8 over 4 is 2. 2 plus 3, y equals to 5. Final answer. Okay, so let's look at that of the horizontal asymptote first. For HA, what do you notice here? The degree of the numerator here is 2. The degree here is also 2. Are you there? So since the degree here and the degree here, they are the same. So our HA occur at y equals to, the coefficient of this S square is 1, Abi. This is also 1. 1 over 1, which is equals to what? 1. So HA occur at y equals to what? 1. But let's verify if there is a vertical asymptote. Vertical asymptotes, we are given this function. What we have to do is that we can factorize. Now, whenever you can factorize both the numerator and what? Denominator, please do so and see if there will be any factors that can cancel out. So here we have s squared minus 4. Here we have s squared minus 5s plus 6. Both the numerator and what? Denominator can be factorized. Are you there? We can factorize this. So what do? We have to factorize, Abi. For the vertical asymptote, we factorize the function. Okay. When we factorize, that will give us y equals to, here we have s squared minus 2 squared. I can apply the principle of difference of 2 squared here. Divided by, let's factorize this and see. The denominator here we have s squared plus 5x plus 6. So when you multiply the first term by the last term, that will give us what here? 6s squared. Okay, so let's factorize this and see. Multiply the first term by the last term. S squared times 6 is 6s squared. So, sorry, this is minus 5x, right? So we have to think of two numbers that when we multiply them, we have 6s squared. But when you add or subtract, that will give us minus 5x. I guess the numbers are minus 3x and minus 2x, right? Because minus 3s times minus 2s is what? Is 6s squared. Minus 3s minus 2s is what? Minus 5x. So that means I will replace this number here with minus 3s and minus 2s. That will give us s squared minus 3s minus 2x plus 6. Between these two terms, what is common is x, Abi. We have x minus 3. Between these two, what is common is minus 2. Here we have x minus what? 3. Okay, so let's proceed. Then I can factor out this. Between this and this, x minus 3 is common. We have x minus 3, all in bracket. What is remaining here is x minus 2. So these are the two factors of this, right? So here becomes, I can replace this with what we have here, which is x minus 3 and x minus 2. So this is same as x plus 2 times x minus 2 from the principle of difference of 2 squared divided by x minus 3 and x minus 2. Okay, so when we achieve that, we will find out that one of these terms here can cancel out. So our y becomes what? Becomes s plus 2 over what? X minus what? 3. Now to find the vertical asymptote, I can now say, let's set our dx equals to what? 0. When you set your ds equals to 0, that will give us s minus 3 equals to what? 0, right? So let's see what will be the value of x. X becomes what here? 3. Therefore, our SD is equals to what? 3. So the vertical asymptote occur at s equals to what? 3. If we want to verify if this answer is correct, what do? We can put this value of x back to this numerator. If the result is equals to 0, it means we are wrong. But if the result is not equals to 0, it means we are correct. Are you there? So let's check this out and see what will be the result here. Let's put this here. By the time we put this here, 3 plus 2 is 5. 5 is not equals to 0. That means our vertical asymptotes occur at x equals to 3. But if at the end of the day, after putting the value of x and we got 0, that means there's no vertical asymptote. All right, thank you. So let's look at one more example, if there is. If there is. Definitely there's no slant because the power of x here and the power of x here, they are the same. The degree of both the numerator and the denominator happens to be the same. So there's no slant. So we only have horizontal asymptotes, which occur at y equals to 1, and vertical, which occur at x equals to 3. All right, let's look at this question. We are asked to analyze the types of asymptotes that can occur in this function, right? We are given y equals to x minus 2 divided by x squared minus 4. Let's start with that of horizontal asymptotes. With that of horizontal asymptotes first. Let's look at horizontal asymptotes. Horizontal asymptotes. Okay, what we notice here is that for horizontal asymptote, we have to look at the degree, right? The degree of the numerator here, n, is 1. The degree here is what? M is 2. And 1 is less than 2. So since n is less than m, we are going to say that our horizontal asymptote occur at y equals to 0. Don't forget, at y equals to what? 0. Okay, so let's look at that of the vertical asymptote. For vertical asymptotes, we have to factorize, right? We have to factorize the expression. We have to factorize the expression, and that will give us, let's see, y equals to x minus 2 over s squared minus 4. So this is already a single factor, s minus 2. By the time we factorize this will give us s squared minus 2 squared. So y becomes s minus 2 divided by x. Using the principle of difference of 2 squared, you will have s plus 2 times s minus 2, right? So what we notice here is that this can divide this. So we are left with y equals to 1 over s plus 2. So what will be the vertical asymptote is that we have to set s plus 2 equals to 0. Therefore, vertical asymptote occurs at y at vertical asymptotes. Okay, vertical asymptote occur at x equals to minus 2. It occurred at s equals to minus 2. All right, so that is the answer here. By the time you put the value of minus 2 to this function, I said to verify, we have to test this and see. When you put the value of minus 2 here, that will give us minus 4. Let's try this and see. Let's verify and see. Putting the value of x as minus 2 give us minus 2 minus 2. The answer is minus 4. All right, and minus 4 is not equals to what? 0. Do you understand the concept here? If after putting the value here, the answer is what? The answer is 0. It simply means that there is no vertical asymptote. Let me show you something. Let's assume that the value we have here is plus 2. Let's see. If I have x as 2, by the time we put 2 here, what do you have? 2 minus what? 2. The answer is what? 0. So since I have 0, that means vertical asymptote does not occur at s equals to 2. But the value of minus 2, after substituting it in this function, the value we had here is not equal to 0. That means vertical asymptote occur at s equals to -2. That is the reason why we have to factorize this. Because if you don't factorize this, you might end up having two possible answer. Let's work. Let's see. Let me explain something again. We have seen this, right? Let me explain something again. In my previous class, I said something about finding vertical asymptotes. I said we set this equals to 0, meaning x minus 2 equals to 0. Is that not? Then it means my x is equals to 2. Is that clear? So that means my Sn is equals to 2. The value of s gotten here is simply our Sn. We also set this x, right? S squared minus 4 equals to 0. So what we have here becomes x minus 2 times x plus 2 equals to 0. So we have x minus s equals to what? Minus 2, or x equals to what? To 2. So what we notice here is that since 2 occur here, these two can go with these two. We are left with what? This. So the value of x here that remains is the value of the vertical asymptotes. Are you there? So these are now way we can solve this. Okay, when you have a common whatsoever, just cancel them out. Any value we have here remains the value, because if I'm to put this back into this function, it simply means that here we have x minus 2, right? Here we have here as x minus 2 and s plus 2. So this, we also go with this. Is that not? So we are left with 1 over s plus 2. Right now we now set this. That will give us s plus 2 equal to 0. So x equals to -2. So this is just it here.